I can illustrate the real number system. This is a Venn diagram that illustrates the real number system, and we, along with our second block class, have come up with some mnemonics that might help you remember. Naughty weasels ignore rules. That's where you get the N, the W, the I, and the R. I like to start from the bottom and go up because these are the numbers you learned first. Natural, then whole, then integers, then rational. Then on this side, we have another one. Iguanas run naked. So I, R, and N. Iguanas is for irrational, and the run naked is for the title of this whole thing, which is real numbers or the real number system. I think this is going to be fun. Let's go on to the next one. The first example here, I have already moved these numbers into the calculator so that they would be easy to see. Okay, they say I can identify the subset of the real number system to which a number belongs. Please place each number in the diagram of the real number system. Well, all of these numbers down here are going to have to be placed in the diagram where they go. But the first thing I'm going to do is put them in my calculator. Negative 10 doesn't change. Negative 3.1 doesn't change. Negative square root of 2 definitely changes. Negative 2 over 7. Square root of 9 also changes. 0 and 4 over 1 becomes 4. So let's go to the next page and see if we can move them into the diagram. So the first thing I'm going to look at is this 10. We know that negative 10, is an integer because integers are all the numbers on your perfect number line. Positives and negatives, never any decimals. The next thing we have is negative 3.1. Negative 3.1 is a decimal, but it stops. When that happens, when it stops, we know it is rational. We also know that if it repeats in a pattern, it is also rational. The next number is negative square root of 2, and that is a crazy number that goes forever. That is definitely an irrational number because it looks a lot like pi when you think about it. The next one is a fraction. We know all fractions are rational. The only reason we put it in the calculator is to see if it changed into something more specific, but it did not. Next, we put in the square root of 9, and it becomes 3. So 3 is a number we learn when we are little bitty, when we are counting tacos. 1 taco, 2 tacos, 3 tacos. Maybe you're counting goldfish crackers, but I'm counting tacos. Then we have a 0. The 0 only can go in one place, and that is whole. Yes, 0 is an integer. Yes, 0 is rational. And yes, 0 is a real number. But the most specific place it goes is the whole numbers right here. Finally, we have 4 over 1, which becomes 4. Another number that we learn when we're little bitty, when we count 4 tacos or 4 goldfish crackers. So that goes there. So that's how you would separate them. But always remember to put them in your calculator just to make sure that they don't turn into something else, like the 4 over 1 became a 4, or the square root of 9 became a 3. Okay, let's go on to the next one. This says the number negative 5 belongs to which of the following sets of the real number system? Choose all that apply. Well, I'm going to go back to my Venn diagram just for a second. So we're looking at negative 5. So we know that's an integer because that's the lowest place where there are negative numbers. So if it's an integer, it is also rational and it is also real. So those are the 3 things we have to pick: integer, rational, and real. Let me get my stylus so I can do that for you. Okay, so we have integers, if it lets me write. So again, we're going to see that negative 5 belongs with integers right here. And we're going to see that negative 5 belongs with rational right above it in the Venn diagram. And we know it's a real number. So if it asked you to choose which of the following sets of the real number system, you have to choose everything that it applies to. It's definitely not irrational, definitely not a whole, definitely a natural, but it is everything else. All right, here we're going to have to classify numbers as different between rational and irrational. The first thing I'm going to type in my calculator is pi. If anything looks like that, where it just has a decimal that goes on forever, then you know it's irrational, like pi is irrational. So let's try the next one, square root of 5. Okay, so put that in. That is a number that looks a lot like pi. So let's go ahead and put it where it belongs. It is irrational. Okay, so let's go to the next one. Negative 3 divided by 4. That's a decimal that stops, but most importantly, it's a fraction. So that is rational. Then we have the next one. Do you see that line over the 1? That means it's repeating 4.111111 forever, and it is never going to stop. So when you have a decimal that repeats like that, that has that repeating line on it, then you automatically know that that is rational. Next, we're going to go ahead and we're going to put in the square root of 20. So the square root of 20, well, look at all those decimals. Sure reminds me of pi. I can even put pi in again just to check. Definitely goes forever, so that is irrational. And finally, we're going to put in the last one, which is the square root of 81. Ah, that turns into a 9. 9 is definitely a natural number, something we learn how to count when we are very, very young. So we're going to go ahead and we're going to move that over to rational. All right, and let's see what else we have. Well, that looks like the end of that video.